Hi, my name is Alyssa Clements, and I am a meteorologist at the Nashville National Weather Service office. This presentation will cover a variety of topics that a meteorologist will typically talk about during a school outreach event. Feel free to use the video chapters to skip ahead to the content that you and your students would be most interested in. Let's start with some information about meteorologists and the National Weather Service. Meteorology is just the study of the Earth's atmosphere and the weather. A meteorologist is someone who studies the atmosphere and the weather, meaning many meteorologists use what they know to forecast the weather. The National Weather Service is a government agency located within the National Oceanic and Atmospheric Administration, which is located within the Department of Commerce. There are 122 National Weather Service offices across the country and in U.S. territories, and the National Weather Service has about 4,800 employees nationwide. Here's a map of all 122 offices, and this red square that you see is where the Nashville National Weather Service is. Aside from the National Weather Service offices, there are also national centers that are very important, such as the Storm Prediction Center, the National Hurricane Center, 12 River Forecast Centers, and 21 Center Weather Service units, which are important in aviation. Remember, we are a government agency, so we are not the meteorologists that you may be familiar with on television. But we do issue weather forecasts, and we are the ones responsible for issuing all weather watches and warnings, such as a severe thunderstorm warning or a tornado warning. Our mission is a simple one. We are here for the protection of life and property. Now let's talk a little bit more about your local National Weather Service office. This map here shows the area that the Nashville office is responsible for. If you're familiar with your Middle Tennessee geography, it's most counties between the Tennessee River to the west and the Cumberland Plateau to the east. We are responsible for 38 counties across Middle Tennessee and more than 2.5 million people. Here's a couple views at our office. The top one is our building with the radar in the background, and the bottom one is a look at our operations center. Our duties include issuing all severe weather watches and warnings. We issue weather forecasts out to 7 days. We also monitor river conditions. We produce forecasts for our major airports. We produce fire weather forecasts. We launch weather balloons twice a day, every day. The National Weather Service is a 24/7 operation, meaning that we work all hours of the day during all days of the year. It's not just meteorologists that make up our team. We have 4 different managers. Our meteorologist in charge is our supervisor and boss of the office. The warning coordination meteorologist is in charge of outreach and events. The science and operations officer is in charge of training and research, and the electronic systems analyst maintains all of our equipment. Meteorologists are either lead forecasters, who are typically the meteorologists who have the most experience, and general forecasters. Most offices will also have a senior service hydrologist who is the expert in all things water. There is also an observations program leader who maintains the observational network, including all of our volunteer weather observers. Our electronic technicians and information technology officer keep all the equipment running, and the administrative support assistant does a variety of administrative tasks for the office, including budget, time and attendance, and making our travel arrangements. Now let's go into more detail about what we do at the National Weather Service. We do produce 7-day weather forecasts that get updated at least twice a day, but it may be more updated more frequently throughout the day as necessary. Our forecasts will include temperatures, dew point, probability of precipitation, the type of weather, sky cover, wind speeds, and precipitation totals. We have special software in our office called the Graphical Forecast Editor that is located on our Advanced Weather Interactive Processing System, otherwise known as AWIPS, that allows us to create the forecast. Here's a look at our special AWIPS computer. You can see that we have 3 monitors because we look at so much data. And here is that special graphical forecast editor software where we do all of our forecasting. All of these little boxes that you see, these are what we call grids, and each one contains a different forecast element. Do you ever want to know what the forecaster was thinking when they were doing their forecast? Once we're done making the forecast, we will write what we call an area forecast discussion, which details all of our thoughts on the weather over the next 7 days. These are available on our website, so you can read it. Our forecasts are also available online. Just visit weather.gov and type in your location in the search bar, or just click on the map where you live. We also do forecasts for all of our major airports, and these are called a terminal aerodrome forecast, otherwise known as a TAF. And it's a special forecast that we provide to airports. These TAFs are updated at least 4 times a day, but they can be updated more frequently if needed. A TAF will give information about cloud cover, cloud heights, wind direction and wind speed, visibility, and if any precipitation is expected over the next 24 hours. These TAFs are important in letting pilots and others know if it's safe to fly, and this is what a TAF will typically look like. We also work with federal and state land management agencies for the prevention, suppression, and management of wildfires. Here in Middle Tennessee, fire weather season is typically from October to May, but wildfires can happen year-round. So we provide fire weather forecasts every day of the year. What good is a forecast if nobody knows how to interpret and use it? Incident Decision Support Services is just a fancy way of saying that we provide the information necessary to our partners so that they can make the appropriate decisions for big and special events. We may provide special weather briefings to them via a webinar, email, or phone, or sometimes a meteorologist will go directly on site to provide support. Radar is one of the most powerful tools at a meteorologist's disposal, so let's talk about how it works. A radar works by sending a beam of energy out into the atmosphere. That beam will continue on until it hits something, such as a raindrop or a hailstone. And once it hits something, then a portion of the energy beam gets sent back to the radar. The radar then processes that information that it gets sent back, and it's smart enough to determine the size and shape of what it hits. It then plots this information on a map. And you may be familiar with this, all of the greens, yellows, and reds that you might see on a radar map. That is all the information that the radar has processed. Now, as powerful a tool as radar is, it does have its limitations. A big limitation of the radar is what we call the radar horizon problem. Because our Earth is round, the further away the radar beam gets from the radar, the higher up off the ground it gets because of the natural curvature of the planet. So this means that we can't see the lower levels of a thunderstorm if it is too far away from the radar. Beam blockage is also a problem for radars. Terrain, such as hills or mountains, can block a radar's beam, which prevents us from seeing what is on the other side of it. There are some areas of the country that also don't have enough radars, so we have a very hard time seeing storms in these areas. Finally, there's also the radar rotation problem. The radar takes time to scan the atmosphere, which at its fastest may be 5 to 7 minutes. Some types of weather phenomenon can be missed if the radar isn't scanning in the right place at the right time. As mentioned earlier, we launch weather balloons twice a day, every day. So let's talk about what this process looks like. While twice a day is the minimum, we can launch weather balloons more frequently if bad weather is expected, such as a hurricane or a tornado outbreak. For us in Nashville, balloons are launched at 6 a.m. and 6 p.m. during Central Daylight Time, that's roughly the spring and summer, and at 5 a.m. and 5 p.m. during Central Standard Time, that's roughly fall and winter. We do launch in every type of weather except one, and that is thunderstorms. Why is that? Well, first, thunderstorms is a safety hazard. You're essentially a lightning rod while holding the balloon. And even if you weren't struck by lightning, the data that we would get back would be bad and useless anyway. Most National Weather Service offices will use hydrogen to inflate the balloon because hydrogen is lighter than air, allowing the balloon to rise. A smaller number of offices will use helium to inflate the balloon. Attached to the end of the balloon is an instrument called a radiosonde, which you can see in these pictures here. A radiosonde measures temperature, humidity, wind, and pressure as it rises about 100,000 feet up into the atmosphere. A typical balloon flight will take about an hour and a half to 2 hours to complete. Here's a look at an inflation building where the balloon is prepared and released. All these red cylinders that you see here holds the hydrogen, which we use to inflate the balloon. And finally, here's the materials we used for the balloon launch in the bottom right, including the radiosonde, an orange parachute, and the balloon. The balloon is attached to a nozzle and laid out on a long table so it can be inflated with the gas. An orange parachute is always attached between the balloon and the radiosonde. Once the balloon pops, the radiosonde will come back down to Earth and the parachute will slow down the instrument's descent. Once the balloon is inflated, it's time to let it go. And once the balloon is released, we have a special computer back in the office that receives data from the radiosondes every second. Now let's talk about some weather basics. Sometimes it's easy to get meteorology and climatology confused. While they are related, they do mean different things. Meteorology is about the weather that is happening right now, and it's the weather that you get. For example, if someone says the high temperature expected today is 82 degrees, that is a statement about the weather. Climatology is climate data that is based on years of data, and it's what you expect to happen, but it might not be what actually happens. For example, if someone says the average temperature for February is around 54 degrees, that is a statement about the climate. A temperature of 54 degrees is what you might expect in February, but it doesn't necessarily mean that it's what you're going to get. Did you know that the sun is actually responsible for all of our weather on Earth? More specifically, it's the sun and the Earth's tilt that helps to drive our weather patterns. During the summer solstice, the northern hemisphere of the Earth is tilted towards the sun. This means that the northern hemisphere receives more direct sunlight compared to the southern hemisphere. During the winter solstice, the northern hemisphere of the Earth is tilted away from the sun. This time, the southern hemisphere receives more direct sunlight compared to the northern hemisphere. And it's the Earth's tilt plus its orbit around the sun that gives us our seasons: summer, fall, winter, and spring. All of this to say that the Earth is unevenly heated. Different parts of the Earth receive more sunlight than others, depending on the Earth's tilt and its position to the sun. The equator, the middle part of the globe, receives more sun compared to the poles. And it's this unequal distribution of heat that creates what we call different types of pressure systems. Have you ever seen a weather map that has blue H's or red L's on it? That's what we mean when we talk about pressure systems. A blue H stands for high pressure, and another way to remember this is that H stands for happy weather. High pressure usually brings clear skies, calm conditions, and dry weather. A red L stands for low pressure, and another way to remember this is that the L stands for lousy weather. Low pressure usually brings cloudy skies, windy conditions, and wet weather. A typical weather map will not only include high and low pressure systems, but it will also include cold and warm fronts. On a weather map, a cold front is depicted by a blue line with blue triangles, while a warm front is shown by a red line and red half circles. When a cold front passes, temperatures will get colder. On the other hand, when a warm front passes, temperatures will get warmer. Fronts will also typically bring precipitation. Let's put your knowledge to the test. Here's a weather map showing temperatures across the southeast United States, but look to the west. What do you see? Hopefully you set a low pressure system in a cold front. The red L tells us it's a low pressure, while the blue line with blue triangles depicts a cold front. Now, what do you think will happen to these temperatures? Look at these temperatures get colder as the cold front passes. And if we continue, the cold front continues to move towards the east and temperatures continue to cool behind it. Now let's back up and let's take a look at weather conditions. You can see for locations near the front, it's rainy and stormy, but well ahead of the front, it's nice and dry. But watch what happens as the cold front moves to the east. Locations that were dry are now seeing rain and storms as the front passes through. And as this storm continues to move towards the east, so does the rain and storms. Now let's talk about the water cycle, which is a very important process in Earth's atmosphere. What is the water cycle? Well, the water cycle is just the path that all water follows as it moves around the Earth. When it comes to Earth's water, most of it, nearly 97%, is found in the oceans. A smaller amount is found in our lakes, rivers, streams, soil, and in polar ice caps and glaciers. Less than 1% of water is found as water vapor in the atmosphere. Water has three states: solid, liquid, and gas. For water to go from a liquid to a gas, we call that evaporation. The sun drives the evaporation step of the water cycle. As the sun heats up liquid water, it changes it to a gas that we call water vapor. As liquid water turns into water vapor, it rises up into the atmosphere where it cools. Eventually, this water vapor cools enough that it turns back into tiny liquid droplets in a process called condensation. This process also is where clouds develop. Eventually, clouds will become too heavy with all the condensed water, and it will release the water back to Earth's surface in some form of precipitation, typically rain, hail, or snow. Once back in our oceans, lakes, rivers, and streams, the water cycle process will begin again with the sun driving the evaporation process. Now let's talk about the different types of clouds. As we talked about in the water cycle section, clouds form during this process. The sun evaporates liquid water, turning it into water vapor. The water vapor rises into the atmosphere where it cools and condenses back into tiny water droplets and forms into clouds. Once a cloud gets too heavy, it falls back down to Earth in the form of precipitation. Clouds are named according to their location and can even help you predict what type of weather is on the way. The highest clouds in the atmosphere are called cirrus clouds. These types of clouds are wispy in appearance and may look like feathers. These clouds are so high up in the atmosphere that they are usually made up of ice crystals. If you see these types of clouds, it's usually a good indicator that it's going to be a nice day, but rain may be in store in a day or two. Clouds in the middle levels of our atmosphere are called cumulus clouds, and cumulus clouds have a puffy, cauliflower-like appearance to them. Cumulus clouds are usually seen in nice weather, but watch out. If these clouds become big and dark, it's a sign that rain, lightning, and thunder are on the way, and tall cumulus clouds are called cumulonimbus clouds. Our lowest clouds are called stratus clouds. These clouds are gray, sheet-like clouds that fill up the entire sky. If you see stratus clouds, you are in for a dreary, rainy day. Now let's talk about the basic ingredients we need for a thunderstorm. For a thunderstorm to develop, we need three basic ingredients: moisture, a lifting mechanism, and instability. Moisture is important because without it, we can't even get a cloud. When we say lifting mechanism, we're typically talking about some sort of front, like a cold front. These fronts do help in the development of thunderstorms. Finally, instability just refers to the ability for air to accelerate upward. This upward motion of air is important in the development of thunderstorms. A supercell is the strongest type of thunderstorm we can get. When we say supercell, we mean a thunderstorm that spins. And to get a spinning thunderstorm, we need the same basic ingredients we just talked about, plus something we call wind shear. Wind shear just means that wind directions change direction as you go up in the atmosphere. Imagine a water bottle in your hand. If you push on the bottom of the water bottle in one direction, but push on the top of the water bottle in the opposite direction, what happens? The water bottle will spin. It's the same concept in our atmosphere. This change of wind direction at different levels of our atmosphere create a horizontal rotating column of air. And when a thunderstorm passes over a horizontal rotating column of air, it is tilted and stretched up into the thunderstorm. And now we have a rotating thunderstorm, also known as a supercell. Supercells are the strongest and longest lasting type of thunderstorm. Supercells are almost always severe, producing very large hail, very strong winds, and tornadoes. Most of the violent tornadoes we have on record originated from supercells. Do you know the difference between a watch and a warning? Well, let's talk about it. When it comes to knowing the difference between a watch and a warning, I want you to have this ready, set, go mindset. Watches are in the set phase, and a watch just means that severe weather is possible. It's not a guarantee that you will get severe weather, but you should be paying attention in case it does happen. Watches will cover a large area, many counties at once, like this image here, and will be in effect for several hours at a time. But when severe weather is about to impact your location, then the National Weather Service will issue a warning. If a warning is issued, then severe weather is about to impact you, and now is the time to take action and seek shelter. Warnings will cover a smaller area than a watch, and they are typically in effect for 30 to 60 minutes. So, to recap, a watch means that severe weather is possible. If you are under a watch, then be paying attention in case severe weather does happen. A warning means that severe weather is about to impact you. If you are under a warning, take action and seek shelter. Let's break it down one more time, and this time let's use cake. If we have a cake watch, this means that we have all of the ingredients needed for cake. Cake is possible, but all of these ingredients have to come together just right for us to get cake. But if we have a cake warning, everything came together perfectly, and now we have cake. Now that we have talked all about the weather, let's talk about how you can stay safe during hazardous weather. And let's start with winter weather. During times of very cold temperatures or wintry precipitation, you should dress appropriately. Wear several layers of lightweight clothing. Consider wearing mittens instead of gloves, as these will keep your hands and fingers warmer. And wear a hat. Most of your body heat escapes through your head. If you are driving during a winter storm or your parents are, make sure you have a survival kit in the car. What would you need in case your car broke down? This might mean extra clothes or blankets and non-perishable food or water. Avoid traveling alone just in case you do break down or get lost, and let someone know where you are going and what time you are expected to arrive. On the flip side, when it comes to heat, it's important to know the warning signs of heat illness. If you become dehydrated, then you may start to feel dizzy, thirsty, or become nauseous and weak. More serious signs of heat illness, called a heat stroke, will be confusion and becoming unconscious. If you or someone you know starts to show these signs of heat illness, act fast. Get them somewhere cooler and get them some water. But if heat stroke symptoms are present, then call 911 immediately. Never leave children or pets or anyone in the car alone and unsupervised. A thunderstorm doesn't have to be severe to be dangerous, as all thunderstorms will have lightning. If you are outside when you see lightning or hear thunder, then seek shelter immediately. Be aware of the warning signs of lightning. If the hair on your arms or head starts to stand up, that's a clear warning sign that lightning is about to strike. Get inside immediately. If you are stuck outside with nowhere to go, then try to make yourself as small as possible. Lightning tends to, not always, but tends to, strike tall objects like buildings and trees, so stay away from tall things. Most people who are killed by lightning are killed by that first or last lightning strike. So we do recommend waiting at least 30 minutes after you see the last lightning strike or hear the last rumble of thunder before going back outside. All right, pop quiz. Where should we seek shelter from lightning? Should it be underneath this tree? No, of course not. Remember, lightning tends to strike tall objects, so you should definitely not be underneath a tree. What about this open field? Nope. Remember, we don't want to be outside. What about this lake? Nope. Lightning really likes water too. But what about inside this nice house? Yes, exactly. We want to be inside. Flash floods are very dangerous because it takes less water than you think to sweep you or your car away. Only 6 inches of swift moving water can knock you down, and only 12 inches of water can float away most cars. So remember this: turn around, don't drown. It's never worth it to drive through a flooded roadway. Find an alternate route. Flash flooding is also harder to see at night, so stay patient or find an alternate route. Hail is also a very dangerous part of a thunderstorm as it can break windows and cause bodily harm. Half-inch hail falls at nearly 20 miles an hour, but the bigger the hail, the faster it falls. 3-inch hail falls at nearly 100 miles an hour. You definitely don't want to be hit with that. So wait until the hailstorm has ended before venturing back outside. Tornadoes are obviously very dangerous, but the number one hazard from a tornado is the debris that it lofts up, which becomes dangerous missiles. If a tornado is threatening you, seek shelter inside a sturdy building on the lowest floor and stay away from windows. Mobile homes are not safe, and if you are in a mobile home, leave and find another shelter. If you are driving, get out of the car and find shelter in a nearby sturdy building. If there is no sturdy building, get in a ditch or some other low-lying area. Cover your head, as that is the most vulnerable part of your body. Why do we say the lowest floor? Take a look at this example. This is a well-built 2-story home on the left. On the right is the same home after a tornado came through. You can see the top level of the home is gone, but the bottom floor is still there. This is why we say get on the lowest floor available. But why do we say mobile homes aren't safe? Mobile homes are lightweight and easily flipped and destroyed. Here's a comparison of an EF2 tornado. The photo on the left is a mobile home that is completely destroyed, while the photo on the right is a well-built home. While it is certainly damaged, you would have been okay on the lowest level of this home. If anything in this presentation interested you and now you're thinking about becoming a meteorologist, let's end this talk with how to do that. If you're interested in becoming a meteorologist, it's important to have an interest in science and math. To become a meteorologist, you'll need at least a Bachelor's of Science degree in meteorology or atmospheric science, and there are many schools across the country that you can attend for that. This map here shows the schools that have such a degree. While a bachelor's degree is the minimum requirement, some will go on to earn higher degrees, such as their master's or PhD. Don't be afraid to reach out to your local National Weather Service office about job shadow or volunteer opportunities so that you can learn more. It's not just meteorologists who the National Weather Service employs. Technicians, administrative experts, researchers, hydrologists, and much more are all important to the mission of the National Weather Service. Everyone is an important piece of the puzzle. Thank you so much, and we hope you enjoyed this presentation. If you have any questions, please feel free to reach out to the Nashville office at the email address on the screen. Thank you so much, and take care.